Okay.
Okay.
To you. Okay. So I will share my screen. Okay. So first of all, right, you have already seen the syllabus. Okay. So I just walk you through the syllabus, right? What I'm going to cover. Okay. So that will be help you. And you guys are perfectly thinking about the data engineering, right? Because see, whatever you want to define, whatever you want to think about data engineering, so decide it properly. Because if you start something, so don't leave it until the course finish, and then you start interviews, because I'm saying you should give the chance for the data engineering at least 2 to 3 months chance you give. Start interviews. I believe interviews will be not easy in the beginning, definitely, because interviews will be like little tough, right? Because you will be starting as a newcomer. But I believe I have seen the people in this my training, or like the people who are coming new, they learn in 2 and 3 months and they got a job. And after job also are sustaining their they are sustaining in the market. Okay.
Okay.
So I'm saying it's a matter of belief, right? You should have belief in yourself. Second, you should have belief in the trainer. And the third one, you should have belief in your practice. Okay. If you have belief in these three things, you can achieve your target. Okay.
Okay.
Okay. So first thing is you have to at least I'm saying in a day, if you can spend 2 to 3 hours a day, that is a good enough for your like a 2 months, 3 months, your preparation. Okay. After 3 months, you can show 4 years experience. I'm saying it depends country to country. Like some countries, like if India, if I talk about, so 3 years is a very good experience. Like it's not more, it's not less. But if I say US minimum 5 to 6 we need. Okay. Or if I say any other country, depend country to country. Like some countries, they say like 3 year, 4 year data engineering is good. Like it's a good positions. Like you can find the job requirement in the market for 4 years experience you can get. Okay. So when we starting the um, so first thing is I have divided complete syllabus into module, right? Okay. So if I say the first module, this is fundamentals of the data engineering. Like we are starting from this module, like to pick up, right, Hadoop component. And Hadoop is the base for the entire data engineering, even though you are learning the cloud, right? So cloud will be using the Hadoop Spark cluster, right? So I will be teaching AWS has EMR cluster, Azure is having SD inside, GCP is having the data prop. So these are the Hadoop Spark cluster on the cloud. So cloud is just giving an environment where you are getting the managed services, right? You are getting a managed services from the cloud. So you don't need to set up and configuration manually, because you are getting a virtual machine, you are getting you are getting a load balancer, everything you are given by the cloud. But Hadoop file system is still in demand, because that is for the large data analytics, right? If you want to store your data in the files, for the large amount of files, right? Data files, and then you want to do analytics on the top of the data, you need to learn Hadoop. Okay. So Hadoop is not a one tool. Hadoop is having set of small component. Okay. So first we have to start from the Hadoop fundamentals, right? We have to understand the Hadoop architectures, and their Hadoop commands comes, right? Hadoop developer command, Hadoop admin command, right? So when we are starting the Hadoop, we are starting from the scratch, right? What is a Hadoop architecture, right? Read and write operation in Hadoop, and basic fundamentals. These are theoretical concept, except this is a practical, because Hadoop developer command we are doing practical, Hadoop admin command we are doing practically. Okay, not all the admin command, because we are not going for the admin position, we are going as a developer position, so we should know developer command. Okay. And the next is a MapReduce nowadays nobody using, but it's still why it is need to learn. The importance of the MapReduce is like all the component is internally doing MapReduce. Okay. So MapReduce is just an architecture. It's a framework. Map and reduce two functions are there. So explaining like what is the MapReduce architecture. Okay. So MapReduce is there. Hive is very important because we are learning entire SQL in Hive. So you guys already know, right? The SQL databases are really important in data engineering, right? Not only in data engineering, if I say Java or PHP or any technologies, and everybody needs a backend server database, right? So where they can store the data permanently. So Hive is similar tool. Hive is giving SQL query interface. It's a giving a table, okay, row and column. So you can read data from the tables using the Hive queries. Okay. So Hive we will learn the same thing, but Hive is giving more additional things than the SQL database. Like partitioning there, bucketing is there, and different types of surveys are there, JSON, CSV, Open, Parquet, XML, regex survey. You can see my YouTube channel. These are all videos are there. If you want to go some advanced learning, right? See, whatever I'm teaching in my training course, I will start from the scratch, but I will go step by step. Okay. But if you are really interested, like you want to go ahead and you want to learn more advanced things, so my playlists are there. Okay. Already my previous batch playlist. You can see my classroom, my previous classroom. I will share you my Google Classroom links, and those classroom links are my previous classroom. Already I have given you in the group description. You can join these classroom links and you can get the benefit of your learning. Okay. See, I have never stopped anyone to learn advanced things. But if I say, if you go step by step with me, that is good. Okay. At least whatever I'm going to teach, if you can learn before just one day before, that is really very amazing, right? Because you will get very good hands-on and good learning. Okay. Like how many types of joins are there? Internal table, external table, windowing functions, Hive optimization techniques, how we can improve the performance of our Hive queries. Okay, Hive transaction management. Next is the Scoop. Scoop is an import-export tool, right? Read the data, write the data to the RDMS. So how can we bring the data? How can we bring the data from RDMS database to the Hadoop file system? So these are the Scoop import commands. So I will do all these Scoop import commands. Next is a HBase. HBase is a NoSQL database. We are already familiar with some NoSQL databases. We have heard the name of like MongoDB, Cassandra. So, and AWS cloud is having the DynamoDB, right? So these are the NoSQL databases are there. Okay. So these same NoSQL databases, Hadoop has its own NoSQL database, HBase. So HBase is a column family database. It's a column family means the some group of column together make a one column family. If I say I have address, so address, how many columns can be there? Address has the street number and house number, city, zip code, and country. So this makes a column family. So it is very simple. I'm telling you, learning is simple if you learn easy way. Okay. If you think like it's a very complex, then it will become complex for you. So first, everything do practice, do step-by-step theory, and do one more thing is like find the questions, find the interview questions, find the how the people are asking questions. I will give you the interview questions. I am attending some interviews proxy, so some interview questions are coming. So these interview questions will help you how the real-time questions being asked to the candidate and how you have to answer accordingly. Okay. So if you prepare well for interviews, I believe interviews is not tough to crack. Okay. So topic by topic is there. HBase is there. Plume is there. Plume is again import export tool, but this is for the semi-structured or unstructured data. You know, three types of data is there in the big data. One is a structured, second one is a semi-structured, third one is the unstructured. So structured data we use in the Scoop, but semi-structured and unstructured data we use in the Plume. Okay. So semi-structured and unstructured data we use in the Plume. So Plume is ingestion tool. Scoop is an ingestion tool. So in big data, we write the pipelines. We write the ETL pipeline, and these pipelines are bringing the data from the source, transforming the data, and write the data to the target. So these ETLs, you heard about some ETLs tools like Talent is there, Informatica is there. These are the ready-made tools. These are drag and drop tools. But when we are talking about the ETL in the data engineering, we write our own custom code in Spark, right? So Spark we are using for writing ETL. Okay. So next thing is a Spark only. So module 2 is completely Spark component. How to connect Spark with like SQL databases, MongoDB, Cassandra, Snowflake, Elasticsearch, and Spark with Kafka integration, Spark with HBase integration. So integration is very important. Suppose you have learned Spark, you learn Spark core, like what are the transformations are there, actions are there, you learn. But now further use case is how you can integrate your Spark with other different tools and technologies, how you can integrate. Okay, so the Spark is basically not only just for the analytics, you can integrate with other systems also, because Spark is a processing engine. Spark doesn't have its own database. So whenever you are processing the data, analytics the data, after that you will be storing the data, either MySQL, Mongo, Cassandra, Elasticsearch, these are the storage, right? So these are the NoSQL database. MySQL is the SQL database, okay? Another one is a NoSQL database. Snowflake is a Cloud SQL warehouse database. Okay, so these are all storage. So Spark is writing the data or reading the data from these storage also. So Spark is very powerful. It is 100 times faster in memory and 10 times faster in disk, right? So Spark is now is so much demanding in the market because of its popularity is like it has hundreds of integrations. You can integrate with any tools and technologies, you can integrate with Spark. So why Spark is getting a popularity so high in the market? Because of Spark is having integrations and Spark is so powerful and the processing speed so faster. Okay. And if you see in the AWS cloud, the some services they are giving a Spark processing, right? Like Glue. So AWS Glue is a service. So AWS Glue is a service which is giving a processing capability of Spark separately. And one more service is there in the AWS, that is a EMR, Elastic MapReduce. That is a you can create a Hadoop Spark cluster on the AWS cloud. Okay. So these are the all Spark related things we will be doing. Okay, Spark stages, tasks. So these terms may be new, like RDD. So RDD is a fundamental unit of the Spark, right? What is RDD? Resilient distributed data set. So how we can have our data when we read in the Spark, it is becoming RDD. So RDD is a unit of measurement, okay, and the data analytics in the Spark, okay. So next form of the RDD is data frame. Data frame is the tabular representation of data. So whenever you are saying the data is a tabular form, right, table, so that is your data frame, okay. And next is the data set. So mostly we are using RDDs and data frame, but sometimes we use the data set also. Actually, I have not mentioned here. So data set is also being used in the Spark, okay. And we have a different programming languages like we use for the Spark, like we can use Python, Scala, or Java. So we'll prefer Scala and Python, because Scala and Python, these are the two more demanding languages for Spark. Okay, if you understand Scala or Python already, or you have a very good idea in Python, it will be easy to learn PySpark, because PySpark is completely implementation of the PySpark is a completely implementation of the Python. Okay. Any question anyone has so far?
No, right now, no.
Okay, it's all clear.
Yes, for me, yes.
Okay. Anyone else except you? Anyone has any doubt, you can ask me, because see, I want like you should have the clear doubt, because you are going to start in data engineering. So you should not have any doubt before starting, right? The how data engineering looks like. Okay. Okay, sounds good. Yeah. So Spark Core, Spark SQL, and Spark Streaming. Three powerful module is there in Spark. We have total 5 modules, but we will do only 3, because other 2 are the Spark Machine Learning and Spark Graph. So these 2 are not being used, right, mostly for the data engineering. For other purposes like data scientists, they use Spark Machine Learning libraries and Spark Graph is used. But we are going to concentrate only on these 3. Okay, so Spark Core with the all transformation, action, RDD, data frame, data set, and what are the types of operations are there, right? And performance tuning is there. The Spark SQL is completely SQL data sources. So whatever I'm saying here, this integrations, this all comes in the SQL. SQL means anything you are getting the data from any source, any data source, that will come as a data frame. Okay, so it will come as a data frame, and like suppose you are reading a data from MySQL, or you are reading data from the Cassandra, Mongo, Elasticsearch, Snowflake, it will be a data frame. Or you are reading any file system data, CSV file, JSON file, XML file, Parquet file, Avro file, any type of file format data, you will be getting as a data frame. Okay, data set is a little advanced of the data frame, like you will get the features of RDD and data frame together in data set. Okay, so data set is so these are the three data structure in the Spark. When somebody asks you what are the three data structures are there in the Spark, you know, right? Data structures, we call it like some like data structures, like we can say list, set, map, or like we can say trees or graph, right? So these are data structures. Why they call data structure? Because you are forming some application based on these fundamentals component, right? Data structures component, right? If I say collections, I'm going to use linked list. So I can write some application using the linked list, right? How to add the element in the list, how to remove the element from the list. So if I talk about what are the three data structure of the Spark, so it will be what are the three data structure of the Spark? That is basically um, data frame, data set, and RDD. Okay, if you understood once these three, I believe your completely Spark is done. Okay. And then further the Spark Mongo integration, Spark Cassandra integration, Spark HBase integration, and joins, all these things, and windowing functions, all this will come. Spark streaming is completely basically streaming module. So there are the two types of processing in the Spark. One is a batch processing, and one is a real-time processing. Batch processing is when you are reading a data from the data sources like files or SQL or NoSQL. So that is called the batch processing. Batch processing means you have already data in your data store, just you are fetching the data. So that is your batch processing. But when you say real-time processing, so real-time processing is when the data is coming as on the fly. Can you tell me the example? What type of data is coming on the fly? What type of examples are there? Anybody has observed any example of the streaming data? Can anyone tell the name? Just tell, have you realized that this type of data is real-time streaming data? Anyone can give the example. I just want to know how much you have understanding about the real-time data or streaming data. Anyone can give the example?
You're asking for data format?
No, I'm not asking data format. I'm asking like what type of data is coming as a real-time data, right? Like, okay, I
That's
say,
like messages.
which one?
Messages.
Yeah, messages are there. Just
Mhm.
take an example of Twitter. Okay, so Twitter, you don't have every time the new data is coming, right? It's not a
Mhm.
history data, right? Once the data is stored and you are getting that data, it is not like that. Like it is streaming data, like hashtags are there. Suppose somebody tweeted just now, so immediately you will get data, right? Or if I say credit card swiping data, suppose you are doing the credit card swiping and it's a real-time data, right? Or some live cricket match streaming is going on, that is a real time. So many examples, right? See, the around the world, if we look at the data, there are the two categories. One is you have already stored data somewhere, that is a batch data. Or second type of category of the data is streaming data. So streaming batch data, even you can do Hive or other tools also there. But real-time streaming only Spark. Or one more tool is there, Flink. But Flink is now not in popular in market, but still some companies are demanding Flink also. Flink is basically UK-based community has developed it. Okay, it's also open source. Flink is very pretty old, but see, market get recognition when the tool is getting popular, right? If I say why Spark got popular, because Spark got recognition because they have explored their community and they have given to the people and people used it. But Flink couldn't do that. Flink was limited, right? So that is the reason now still after the 10, 15 years, 12 years, Flink is still not recognized. It is keep trying, but Spark is making dominating. because Spark has already made it its presence powerful. Okay. So that is the thing, like there are many streaming other tools also there, like new tools are coming. But I'm saying still Spark is in demand because it has real-time streaming and batch, both are together in a single tool. Okay. So Spark is not saying you should use for me as only for streaming. You can use for me as a batch processing also, because it has capability of both. Okay. So Spark is very powerful for both. But we will see that how we can integrate the Spark for like Kafka. We can like Kafka is there, and we have other streaming sources, Twitter, Kafka, or REST APIs. We know that like sometimes we are calling the REST services. So REST services we have to learn. There is a request and response module is there in Python for REST API. How can we write our request and response module to write REST API services? So we have to define some REST services API. So two things are there in the REST API. One is the REST services you are exposing and some people who are consuming. So one is a consumer, one is a producer. So same Kafka is also producer and consumer tool, right? Like basically it's a broker. So Kafka is taking the message produced by someone and consumer is received the message from the broker. So Kafka itself is a broker tool. It's like a server. Kafka is a broker server tool, which is consuming the message, which is reading the message from the producer, and consumer is reading the message from the broker. It's a push and pull mechanism. Okay. So we will see here how Kafka is integrated in the Spark and what is the checkpointing is there, what is the watermarking is there. Like checkpointing is basically your data should not be lost, right? Because streaming data is coming continuously. Suppose in case, right, while you are consuming your data, your server is down, your Spark is not able to receive the messages. Okay, it is got crashed or your machine is down. So in that case, checkpointing is the concept which is storing your data in a buffer. Okay, so there is a checkpointing directory is called. There your data will be stored. When the server is up, then your message will be received. Watermarking is another one more concept, like sometimes your data is getting delayed. Okay, your data is getting delayed and your streaming is not able to receive those delayed events. So watermarking, you can set the time. Okay, you can say, okay, 10-minute wait for my messages. So your Spark streaming will wait for 10 minutes for your messages, right? So your messages will not be lost. Okay, so that is the watermarking. So we have to see these concepts, not only theoretical, we have to learn, practice and use in the real-time examples, right? Okay, next third module is a cloud technology, because cloud is very important nowadays because everybody is having the requirement of the cloud, because cloud data engineer requirement is there. It could be a AWS data engineer, Azure data engineer, or GCP data engineer, depend on the which cloud the company is using. But if we learn at least two cloud, because now the market is a multi-cloud. Multi-cloud means if you say, okay, I will like to learn only AWS, it is not sufficient, because AWS cloud, only AWS requirement you will get. If you know AWS Azure, at least two cloud, or AWS GCP, two clouds, then you can easily get more markets. So you have to make it your profile visibility more so that you can get the more calls, and it will be an advantage, like you will be working in project. So the cloud services you will be very familiar and then you can start work. So when we are starting a AWS cloud, first we need to understand the cloud platform, right? What are the storage are there in the cloud, databases are in the cloud, warehouses in the cloud. So cloud is giving everything. You don't need to go anywhere else. Everything you will get it in a one single platform, everything. Okay. So, but you need to decide, there are multiple options also there, right? If I say for Spark, there is a EMR also there and Glue is also there. So what you would like to use? So if I say, if I want to use Hadoop services as well as I want to use Spark, I will definitely go for EMR, because Glue, if I go, I will get only Spark. So if you get only Spark, you can't use Hive, right? So you can't use the Glue in that case. You have to go for, because if you see the Glue here, so you cannot use the Glue in that case. So you need to decide your requirement. You need to decide, like you have to find out the requirement from the client, what they are looking for. Okay, Lambda is like computing, like serverless computing. So you can write any Python code in the Lambda. Suppose you say, I want to write a Spark code. So you can use Glue. So there are two choices are there. Normal Python code you want to write or PySpark code in the Python you want to write. So if you want to write simple Python code, you can use AWS Lambda. There are multiple language support is there. Like you can write Lambda in Java, Node.js, C#. Okay, different languages are there. But if you are going to use Lambda for Python, you can use. But when I say I want to write a Spark code, I will use the Glue. Okay. So here the variations are there, tools are there. So you need to do the analytics on the tools, right? Which tool is most suitable for your requirement. Like if I say I want to use a data warehousing tool, so there is a only choice for you, Redshift. Redshift is a very powerful tool in the AWS, and it is for petabyte of data you can scale up and scale down, and you can do the analytics of the petabyte of data. And there are the other tools like for the reporting purpose, there is Elasticsearch. So there is a OpenSearch service is there. OpenSearch is a service which is providing you the Elasticsearch, and SageMaker is a reporting tool. Okay, so some of the machine learning part we will not go through it because I want to keep it this only for data engineering. Okay, see, machine learning itself is a very vast. Okay, I don't want to say, okay, I will be doing the data engineering whole and the data science also. This is not data science. I have written here basic fundamental introduction. I will give you what are the algorithms are there in machine learning. Even I have not worked on the machine learning, so I can give you the knowledge on that. But what I know about the machine learning, the basic fundamentals, and I will prepare you at least if you get a chance also machine learning, right? Machine learning as Spark ML module, you can use it. Because Spark ML is machine learning libraries are there, ready-made libraries and functions are there. You can directly use Spark ML. So Spark ML is very powerful. But why I'm not covering to that? Because mostly projects are not a machine learning project. Like 80% project are a data engineering project and 20% project are data engineering plus data science. So data science project, very specific demand is that, and you can prepare once machine learning, you can go for Spark ML also. Okay. These are the all AWS services like security and Azure. Azure is having the Azure Data Factory, Databricks, how to use a Azure relational database, right? A relational database like SQL database tool is there, SQL Server. Okay. And we can use analytics using the Synapse is there. Azure Data Factory is the ETL pipeline. So it's a completely suite of Azure services. Okay. So all the Azure services are there in the Azure Data Factory, Databricks. Okay. Azure Databricks is a common service. If you learn Azure Databricks, if you learn in AWS, the same Databricks is there in the Data Factory. The only difference is how the cluster is created in Azure, how is different the cluster is created in the Azure and AWS. Okay, but Databricks altogether, it's the same thing. So there is no difference. If you implement your Databricks, so you will get the live table, delta tables, okay, Unity catalog. These are the specific to Databricks concept. Okay, so those will come in the learning of the Databricks. Okay, so GCP having its own platform, completely all the Google Cloud services like Google Cloud, the Dataproc. The Dataproc is the Hadoop Spark cluster. Same EMR is in AWS. PubSub is there. PubSub is like a message broker tool. Okay, so PubSub is a message broker tool, and like Composer is a Airflow, like orchestration tool. Like suppose I want to schedule my job. So these days, like the Airflow is being used very heavily. Airflow is a powerful tool which we can write a DAC file in Python and we can schedule any type of job, whether it's a Spark.
Ondela.
Okay, so what I'm talking about the GCP services. So GCP has some sort of services, Composer, data storage, BigQuery. BigQuery is a data warehouse tool, and there is a NoSQL database called Bigtable. Okay, so Google has a less demand. Okay, I'm not saying like the first one is the AWS, second is Azure, and third one is the GCP. So you can prioritize which cloud you like and which cloud you think like which cloud is good in the which country. Okay, accordingly you can plan it. but I'm covering mostly AWS first 70% and rest 30% is Azure GCP, because my more concentration on the AWS, because AWS is more demanding everywhere. Okay. Anyone has any question regarding the cloud services? Anything on these three clouds, right? What are the services? So these are all come one by one only, because all the cloud is not possible in a one go to learn, right? Step by step cloud. So if you get a good hands-on on one cloud, I believe second and third cloud will be easy, because when you understand the services of the one cloud, at least one cloud, any one cloud, so you can easily switch to the other cloud. Okay, because you need to understand the what are the substitute services are there. If I say PubSub is in the GCP, so what is the equivalent services there in the Azure? Okay, what is the equivalent services there in the Kinesis there in the AWS? Okay, what is the services there in the Dataproc is in the GCP for Hadoop Spark cluster? So EMR is the Hadoop Spark cluster in AWS, and SD Insight is in the Azure. Okay, what is the Airflow is in the GCP, that is a composer. In AWS, it is called MWAA, and in the Azure, it is the Airflow service. So these are the just terminologies change, but altogether it's working is the same. Okay. And module 4 is completely 3 services, 3 tools: Snowflake, Airflow, and NiFi. Okay, so this is covering the Snowflake, because Snowflake is now getting more demand in the market, because it's a very good cloud SQL data warehouse tool. NiFi, Airflow, okay, these are the tools. And NiFi is basically a pipeline tool, ETL pipeline drag and drop tool. You can create a processor in the NiFi. You can read the file, write the file. You can read the data from Kafka topic, write the data to the Kafka topic, publish and consume the data from the Kafka topic, and you can get the data from SQL data. So there are around 150 processors are there. Even you can use the cloud processor also, like AWS, Azure, GCP. It's a very, very vast tool, but I'm saying at least 10-20% if you are able to do a NiFi, that is a good enough. At least you should have some understanding about how to create a processor, how to create a pipeline in the NiFi, how to configure the pipeline, how to integrate the NiFi with the Spark. So those things are good enough, right? Okay. So these are the NiFi content and DevOps. This is the last final module, and that is very, very important nowadays in the data engineering, because everything nowadays coming on the containers. We are hearing a lot about the container, like people are talking about containers. And containers are the lightweight, and it's very like a fast and easy to boot up, right? And it's like a lightweight. Those are a lot of features are there if you compare with the virtual machine. So virtual machine is like a overhead, okay, and now that overhead is overcome by the containers. So why this data engineering has a DevOps, right? So data DevOps is not like tools and technology. It's like a, we can say, paradigm, okay, and it's basically giving a like approach, right? How you can create your infrastructure. So any project like Java, PHP, Python, every project use the DevOps. So data engineering is using DevOps. It is called DataOps. DataOps. So data plus operation make it DataOps. Like that is a DevOps operation. Okay. So we will learn. We are already learned these tools, how to install these tools in the Ubuntu VirtualBox machine. But suppose if you want to go for installation of these tools in through the DevOps containers, that we have to learn, because nowadays people are expecting you should be having equal knowledge of the DevOps, right? You should not be very expert in the DevOps, but at least you can understand and you can work in the data engineering using the DevOps tool. So one tool comes the Git. Git is very powerful, and we need for the code repository, because we have to maintain our repositories. We have to maintain the code in the some centralized repositories, that is called Git. So Git is a code repository management tool. We have to pull the code, push the code, commit the code, right? So these are the features of the Git. Next thing comes to the Jenkins. Jenkins is a CI/CD pipeline. And basically the CI/CD pipeline is like scheduling a job, right? So we can have a different options in the Jenkins. Jenkins is having multi-branch pipeline, multi-stage pipeline, and we have a different stages in Jenkins. We have clone stage, build stage, test stage, deploy stage. So these are the stages are there. So Jenkins is like infrastructure automation deployment tool. Okay. So Jenkins is very powerful and we use for the any, not only the data engineering, it can be used anywhere. Okay. Next is a Docker and Kubernetes. Docker or Kubernetes is a container management tool. So container management tool, like we use all the infrastructure of the data engineering, we will manage by the Docker pipelines. So Docker, we have a Docker tool, which is having a containers. Like we have a Docker Hub is a registry where we store our images, and Docker volume, Docker compose. These are the all small component of the Docker. And next level of the Docker, and one pipeline we will do, like how the Docker can be used for the Kafka, Spark, Cassandra, ETL pipeline. The same pipeline we can do without Docker, and same pipeline we can do with the Docker container. So you will see when you are doing with the without Docker, so you need an infrastructure already in place in your on-premises. But if you don't have the infrastructure on-premises, right, so you can set up the infrastructure by using Docker container within a 3 minute. Within a 3 minute, you will set up like cluster you are going to set up in 3 to 4 hours. That cluster you can set up within a 3 to 2 minutes, you can set up by using Docker container. So you can think of Docker container is so much powerful. Kubernetes is the one more advanced level of Docker. It is giving a orchestration. It's a multi-cluster environment setup, because Docker can handle only one container at a time. But if you have multiple containers, so there is a utility called Docker Compose. And Docker Compose, like we can say similar to like Kubernetes, but Kubernetes is more advanced and powerful. And Kubernetes, we have the Helm chart and Kubernetes deployment, services, pod. So whatever applications we are saying we are deploying in the as a container, so that is called here the pod. So pod is a definition in the Kubernetes, like one application which is deployed in a container is called pod. And services, like we are having inbound and outbound services, like we can define, like we can do the controller application deployment. So high availability, scalability, these are the features. Kubernetes is implementing microservices. So if you heard about the microservices architecture, why we are talking about every time microservices. So microservices giving a broad idea, right? How you can scale up, scale down your services, right? So how you can do this, right? So this all things are done by Kubernetes. Okay. So we are not going very in depth of Kubernetes because we are not learning DevOps as a like our technology. We are learning Kubernetes, Docker up to the extent so that we can manage our data engineering work, right? So anything which is related to data engineering, DevOps, we can easily handle that. So we can do Helm chart, and we will be doing some pipeline using the Helm chart for the data pipeline, so that we can learn how Kubernetes helping us to the set up the infrastructure, okay, tools. And one more tool is there that I have not mentioned here, Terraform. So Terraform is infrastructure as a code provisioning tool, IaaC, infrastructure as a code provisioning tool. So suppose you want to set up an infrastructure in AWS, like you want to create an instance, you want to apply a security group, VPC, and then you want to do some deployment. So everything can be possible automatically, right? You don't need to go to your cloud AWS. You just create resources. You create a resources and you just select the cloud, which cloud you want to do. And Terraform has the capability to do for all three clouds. Like it can work for Azure, it can work for GCP, it can work for AWS. Okay. So I'll show you Terraform also. Terraform is like is a tool which is the last tool of the DevOps, which we have to do infrastructure as a code. Okay. Now the thing comes like how to do setup, right? This is the entire syllabus, and it is pure theoretical and practical syllabus. Now the setup things, once it comes to you, right? How to do setup. So first of all, you need a virtual box, because you are doing the setup in the Windows. You need a virtual box. So you download the VirtualBox. So VirtualBox, you can get the Oracle website, Oracle VM VirtualBox. There is a VirtualBox 7. You download the VirtualBox Windows host. It is a exe. When you click on this, it will download the exe, like this exe. And once this download, and then you can run this exe. And once this exe run, then you will get the interface like this. You will get the interface like this. And once this interface comes to you, the next thing is you have to start. So you have to create a one virtual machine. So you will go to the new icon, and here you will select your new virtual machine. I say my Ubuntu VM. Any name you can give, okay? And then this folder will automatically come to your default folder in your user ID folder. And this is the ISO. So one ISO file you have to download. I show you. The ISO is the Ubuntu desktop ISO. So 23 version you can download. That is the latest version. So 23.04 version you can download. And this 23.04 version, so this 23.404 version you can download. Like you can go to the Ubuntu 23.04, like here. So once you go here, download this ISO. Okay, I think this is not. Yeah. So this 23.04, you download this image. And once your image is downloaded, this ISO file, keep it in some software folder. Don't keep it in download. Go here in your software folder, C drive, you go to your software, and software folder, you keep it your ISO file here. Like I kept it my ISO file here. Okay. Keep it your ISO file here. Then you will give your ISO file path. You give your ISO file path here, and then automatically it will ask you Linux or this. This is automatically selected. And next is when you go to next here, change your username password. If you didn't change, what will happen? It will create a username this, and password is default password. So just change, like, okay, I want to keep it my username Hadoop, or you can keep it your username, what you can remember, right? Username and password, you can give simple password. Okay, suppose I want to give like password Hadoop. Okay, so once I give the password Hadoop, the same password, you keep it here, and you can install this virtual machine. So you give this, and next you go, and here is a very crucial, because you have to set the RAM and disk for your machine. Okay, so because you have to set the RAM, like depend on your machine RAM. My machine is 64 GB RAM machine, so I can give up to 50 GB. Okay, 50 GB, 55 GB I can give. So you can select your RAM, and if you have more than one processor, right? Mine is 28 CPUs one, so I can give up to 20, 14, right? Like I can give. So you can give the processor, CPUs, and your memory. Go next, and here this is the disk of size. So disk size, you can choose how much disk size you have in your machine. So if you have disk size, suppose 100, or maybe like a 500 GB disk size, and you have maximum, like what minimum you can try, I will say 100 you try minimum, because if you are going less than 100, what will be the issue? Because if your disk is full, then it will be difficult, right, to manage your disk. Okay, again, you want to increase it, but it will be giving an issue to you. So make it maximum as maximum. You try in the one go in the beginning, and then go next to like finish the step. Once you finish the step, or this step, once you finish, it is a very simple step. Nothing is complicated. Create a virtual machine, allocate your disk, allocate your memory, and give your ISO file. So everything is mentioned here. Your ISO file is this, your memory is this, your disk is this, everything is there. Okay. Once you done this, then finish this option. And after that, you start your virtual machine. If you start it, it will take 30-minute time to install as the operating system, like this Ubuntu operating system will install. So Ubuntu operating system once installed successfully, once your operating system installed successfully, after that, you can log into your virtual machine. Once you log into your virtual machine, there is a first step what we have to do. So this is just the virtual machine is ready on your ready. Your virtual machine is ready your virtual machine is ready by Ubuntu. Okay, so your virtual machine is ready first. Virtual machine. Okay, virtual machine is ready with Ubuntu on VirtualBox 7. Okay, and we will be taking Ubuntu 23.04. So this is the first step. Once your virtual machine ready, you are logging into your virtual machine Ubuntu. Once you are logging, so second step, you have to log in your VirtualBox Ubuntu. Okay, and then after you have to do some configuration. I will share one document, like you have to install Chrome. You install Chrome, right? Because by default they gave Firefox, but we install Chrome. Okay, I'm showing to you because mine is already created. Okay.
Well, so one question, right? What is the difference between the Ubuntu and the VirtualBox 7.0?
Ubuntu is like operating system, and VirtualBox is a guest machine where you are doing. Okay, both are different. No difference. Okay, without VirtualBox, host your operating system. You can't set up your Ubuntu without VirtualBox. So VirtualBox is a hypervisor. Hypervisor is like a platform which is hosting your Ubuntu operating system, right? Because you are running on the Windows. So Windows, you cannot run Ubuntu directly. So you need a hypervisor. So VirtualBox is a hypervisor. Hypervisor is a term, like it is like a mediator. It's like a third-party mediator, like Oracle mediator, right? Which is providing. There is another one is like VMware. If you heard about the VMware, is a company who has also. So VMware workstation is there. So VMware also you can do. I have also VMware, but I suggest use VirtualBox like VMware horizontal client. Okay. So this VMware also you can do. VMware has many products. So one is a VMware workstation. I think this one, VMware workstation 17. So if you install this one, you can also, this is also hypervisor. Hypervisor is like a intermediate component which can host your Linux operating system. Once you get your operating system here, the first thing you have to do installation of the Chrome. I already mentioned all these steps are given in a one document. I will give it. You can make it set up. And anytime any difficulty, you can ask me. But I believe, right, very explanatory. And this terminal will not come by default here. You have to go here and you have to search terminal. Then you can add, right click and add the terminal. Right click and add. Because mine is already added. That is the reason it's saying to remove. Okay. So you can add the terminal and you have to add a Chrome and what else you can do. Okay. So once this is ready, next thing is we have to install Hadoop. So Hadoop, we have to install Chrome. Okay. And next we have to install Hadoop on Ubuntu. Okay. So now we will start one by one all tools. So first we will go Hadoop. Next we will go Hive. Then we will go Scoop. Then we will go HBase. Then we will go Flume. Then we will go Spark. Then we will Python. Then we will go Kafka. Then we will go for Mongo, Cassandra, Elasticsearch, and we have other tools, NiFi, Airflow. So everything will be on the Ubuntu, but it will be a step by step. First, we have two tools for initial 5-6 classes, Hive and Hadoop. Then Hive and Hadoop is just a 10-minute things to install, nothing to like take too more time. So you go on the, I have a step in my document, just directly follow my step, or otherwise, if you want to install Hadoop on Ubuntu, you can follow one link. This link is very simple and straightforward. Okay. If you go to install Hadoop on Ubuntu, this Phoenix Snap, if you go here, you have to install JDK 8, Java you have to install, and then you have to install SSH client. Everything is there. This step you don't need to do. This step you don't need to do. This you have to skip this create Hadoop user. After that, you will move to this all steps you have to do. So this steps already written in my document. It's a 10-minute thing to install. Once this is done, next you have to do Hive. So same document for Hive also there, but Hive can be installed when you have Hadoop on your machine. If you don't have Hadoop on your machine, you can't go for Hive because Hive is completely depend on Hadoop. So Hive you can go by installing the Hive using the Hadoop after the Hadoop. So you have to follow this Hive installation. So you have to download the Hive libraries. If you go to the Hive official page, there is a Hive 3.1.3 version. So when you click here, you can see Hive 3.1.3. So this version you download, just click it and then WinTar file. So all steps are given. I have my YouTube video also. If you follow my YouTube video, there also the all installation steps are there. You don't need to worry about it, like how to do. Everything is well explanatory in my steps. Okay, so there is a video name is the installation. Okay, so you can see Hadoop Spark installation. So in this Hadoop Spark installation video, you can see the installation. If you can do all installation, it is up to you. Okay, if you can do all installation, like this is the Hadoop Spark installation. This is the Hadoop installation. I'm doing a Spark installation. I'm doing other tools like Plume, Spark, Hadoop, everything we installed. Okay. And I will share these tools once all installed, you can make it ready. But if I say for initial, at least Hadoop and Hive, these two are required for your starting of the session. Okay, because I will start the Hadoop practice, like Hadoop command practice, like we were discussing about this one. The initial 4 sessions, we have to do this Hadoop, MapReduce, and Hive. These are the 3 tools. And then Scoop and Plume, HBase, these are just 5-minute installation. Okay. So total these installations will take 30 to 40 minutes. Okay. If you are following properly, so it will not be taking much time. So, but I'm saying you keep it ready by 10th of Feb, you start, you keep it ready, Hadoop and Hive. Okay. If you get any difficulty and just ping me in the group. I have a person like who has already done. Okay, I will assign that person and that person will help you. Okay, but you should install first and try it out. If you try it out yourself, you will learn. Because if you get difficulty, then you will try to find solution. Because I have done installation 100 times, I know right what is the problem. But I want you should troubleshoot your problem and you should try to solve your problem, because troubleshooting skill is very important, right? Specifically for installation of the tools. Okay. So start this one. First, keep it ready and keep it your machine at least 16 GB RAM so that you can give at least 10 GB RAM to your Ubuntu. Okay, 10 GB RAM you can give to your Ubuntu so that you can work easily. Okay, if you have a more RAM, it is well and good. Suppose you have a 32 GB RAM, 64 GB RAM. If you have desktop PC, use that one. But at least give 10 GB RAM so that your virtual machine Ubuntu will work fast. Okay. If someone wants to do in the cloud, so AWS instance also you can do same thing, but only 1 or 2 component you can do. Hadoop and Hive you can do, but everything is not possible, right? Because it will take more memory and more disk, right? So for time being, you can do in AWS EC2 instance like Hadoop and Hive, because there is a Ubuntu ready-made is there, right? Just an image. Okay. So you can create a virtual machine there. Ubuntu virtual EC2 machine you can create. Okay, but for practice fine, but for long-term practice you keep it set up in your local machine, in your home PC. Okay, so anyone has any questions can post in the group. Okay, I will address those questions. Okay, anyone has any discussion, any questions, so you can ask me. Yeah, thank you.